Hey, hope your June is going well, and I hope your first weeks of Intel Math are going well. And we're going to start our June MLCs here with this little session. And in this session, we're going to focus on the idea of problem solving. Part of what we hope to accomplish through this project is to help cast a vision for teaching mathematics from a problem solving point of view. And so here's a problem I would like you and your team to engage in, called the dart problem. And in this dart problem, you're playing a dart game where the only two scoring areas are 5 and 11. And the question is simply stated, not a simple question, but it's simply stated, what's the highest score you cannot get? Now, sometimes people see this and all kinds of questions dart through their brain, and if I was with you in person, I would let you think for a while, but since I'm not there with you in person, I want to try to push you in the right direction. And so you can throw as many darts as you like. And so what do I mean by what's the highest score you cannot get? Well, for example, it doesn't matter how many darts you throw. You cannot get a score of 12. You could throw a dart and get 5. You could throw a dart and get 5. That would be 10. But then there's no way you get a 2. So 12 is a score that cannot be obtained in this game. But is it the highest score you cannot get? Your job is to work on this problem and try to find the solution. What is the highest score that cannot be obtained? Now, as you do this, I'm going to ask you to engage in the problem individually to make sense of the problem. Think about a possible solution strategy. Don't necessarily just run off and work to solve it on your own. First, just think for a few minutes about what you might try to do. And then share your strategy with the team. Maybe each one of you could say, well, I was thinking this and I was thinking that. And then as a group, decide how you'll proceed. Will you all kind of engage together and work together on one of the strategies? Will you break off and each do your own thing? Or maybe two people do that, one person do that, whatever. And then as you work through the problem, I can imagine, because I've done this before, I can imagine that you might flow in and out of strategies and in teams. So you might grab somebody and work over here and then jump over there and then go off by yourself and whatever. Allow that to happen. Just flow in and out of working on different strategies and different teams. And then once you think you have a solution, I would like you to be prepared to share your solution with the team. And I say there, work to convince others that your solution is valid. We like to say that sometimes students or teachers I work with will say, well, is this answer right? And I say, it's not for me to decide. The authority resides within the mathematics. So if you can provide a convincing argument that is mathematically sound, that convinces others, then we'll say that that's a solution. Then after that, reflect on your experience. How long were you willing to engage? Like think back and after 3 minutes and you got kind of tired or you got frustrated, or did you give up? Did you give up for a while and come back in? Well, what happened in your experience that allowed you to kind of flow in and out of, maybe flowing in and out of strategies and teams, but also flowing in and out of even trying to accomplish the task? And then also I'd like you to step back and just look at what mathematics did you use during the process. Now maybe it was mathematics that you found out didn't help you arrive at a solution, but maybe it was mathematics that did. We want you to be aware of both. So these are the kinds of things you will post when you're done with this experience. Have fun with the dart problem.